Hello there and welcome to this challenge. That's day 4 of 30 Pandas Library Challenge. My name is Valentine and I'll be your instructor. In this session, we are going to be going through a set of concepts in relation to the Pandas library that will help us be able to perform data analysis, manipulation, and generally help us prepare data for further analysis, whether that is data visualization or just generally analysis. So let's get started. The first thing that you need to do is to go to the video description and you'll find the link to this page. So once you have clicked on the practice resource link in the description section, it should take you to this page, and then you can click on the sample practice resource. So the sample practice resource will give you the concepts that we're going to be covering for today's challenge. If you're an after work member, you can always just visit the link and you should be redirected to this particular page where you can get to work on the practice notebook. The practice notebook is just similar to the sample notebook. The only difference is that the sample notebook has just a few challenges as opposed to the practice notebook. And when you become an after work member, you get access to all the resources, including the solution notebook for this session. All right, so let's get started. The first thing that we need to do is to save a copy in Drive. So go to File, then save a copy in Drive. I'm using the practice notebook, but you can use the sample notebook to do that. So go to File, then save a copy in Drive. It should open a new copy of the notebook in a new tab. So I'm going to just open mine in playground mode. I don't want to create another copy. So let's do that, save a copy in Drive. And once you have done that, you need to click on Connect to connect this notebook to Google Service. Once you have done that, the next thing we need to do is just to install the prerequisites, which is just Pandas for data manipulation. If you realize that I'm too fast, feel free to pause the video to also rewind so that we're all on the same page. All right, moving on, data aggregation and grouping. This is the first concept that we are going to go through today. We already know, if we've gone through the other previous challenges, that we can group data by simply using by grouping data. It just means creating a summary table or a pivot table from a bigger table, and we can use the group by function to do that. In our summary table, we want to group the data by branch and have the sum of the amounts for each and every branch. Then we apply the reset index function to just get a Pandas data frame format as the final table. So we do that. We want to create a summary table with branch and amount. That's the total amount, and we print that out. Let's first of all load this data set, by the way. This is how the data set looks like, and what we want to do is to have the branch. For each branch, we want to see the sum of the amount. So let's run this, and we should be able to see that we have our amount. So branch A, B, C, and the sum of each of branches. All right, pause the video and then work on the challenge. Moving on, selecting a range of rows and columns by label. So sometimes you might want to select data and also select the specific columns that we want. Let's say we want to select all the records, but we also want to select only the account number and account balance columns. So how we do that, we can do it. You can do that operation through various operations, but one of the easiest ways is just using the lock method, which allows us to be able to specify the records that we want, as well as the specific columns that we want to work with. So let's load this data set. And then once we have done this, we want to select account number, which is this one over here, as well as the account balance. And then we want to select actually all the records. So we reference the original data frame, df, then we use the lock method, square brackets, then we specify the first thing as all the records within that data set. So that's where we use a double column, comma, then we pass a list. A list will contain the column names that we want to work with. So we want to display, and then we save that in selected data and preview that. So that's what we have. Pause the video and then work on the challenge. So sometimes you might want to handle missing values, and there are two ways. Okay, there are many ways, not two ways, but there are two sections in this notebook that we are going to cover how to handle missing values. But the first method that we're going to cover is what is called arbitrary imputation. So we can decide that for the records that we have in a data set, and those records have missing values, we can decide to replace those missing values with a specific value or constant. It could be 0, it could be 10, it could be 20. So let's load this data set. We check for missing values, but you can already see some few missing values, but you can check for missing values across all the columns by using the isNull and sum function as shown. So here we can see that we have income with 1 missing value, account balance with 3 missing values, loan amount with 6 missing values. To perform arbitrary imputation on one of the columns, we can decide to, actually not one of the columns, all the columns, we can decide to use the fill function, and we apply it to the data frame. That's the data frame. And we specify inside that function the specific value that we want to use for all the missing values, and we set in place to true to apply this operation that we have here to the original data frame, which is data. So that's what we do, and the result of this will have all the missing values being replaced by the value 0. We can specify any value that you want, but we would have to specify it here. Sometimes you can do mean of that column, etc., but now we can do it here. And note that we're doing this for the entire data frame, but if we wanted for a specific column only, we could have just selected the column by reference the column by just saying, let's say, loan amount, etc., and that would have been able to we would have been able to make our change. But for here, we're just doing everything, and we check for those missing values, check for whether our operation happened, and we can see we don't have any other missing values. So arbitrary imputation, it depends in whatever use case that you might have, but in many cases you can explore other methods. You'd first probably want to determine what those missing what those records with missing values are, then be able to do some further operations on those, or be able to maybe impute using arbitrary imputation, or by mid, by mode, or you could decide to drop those missing values. You could decide to impute them by machine learning techniques such as KNN or random forest, etc. Right, pause the video and then work on the challenge. So exploring a few more steps. So we might want to perform some other, let's say, operations when it comes to missing values. Like for instance, you might want to drop the missing values based on not the missing values, drop the records with the missing values if only one column has missing values. So for example, here we can drop, here we specify that we want to drop, we use drop NA function to specify that we want to drop the records or rows. But now the subset here parameter takes in a list that contains the columns, the column names. It contains the column names that we want to use for this operation. So we want to drop records with loan amount values null. So if loan amount has missing values, then we are going to drop that record. And we can specify more rows by simply adding more items to our list. Then we set in place to true to apply that operation. That's one of the ways, dropping rows with missing values. If we wanted to drop everything, we could have just not used this. If we wanted to drop any instance, any record that has any instance of missing values, then we could have just used it, used what we have here. If, for instance, in some other cases, we wanted to replace missing values using some specific technique like interpolate. Interpolate allows us to be able to use various techniques like linear method, which specifically allows us to be able to apply some sort of to determine some sort of relationship, some linear relationship between the existing values within the data set and the linear and the missing values. So for example, for income, we apply this statistical method to be able to determine what those missing values could be within that particular variable that we have here. And yeah, so that's also another way. So let's run this to be able to just be able to perform those two types of imputation techniques. Not imputation, we drop. So we drop the missing values. So with this, we can be able to drop the missing values with loan amount. So we'll drop with loan amount, and also we drop for we also impute for income, which we do here. We have that, and we could also decide to also handle account balance, but we just leave it as it is. But it's important to also investigate those missing values, those records with missing values, to determine whether the records themselves are actually genuine records, and to also see what would realistically represent the missing values if we were to impute. By impute, just replace values with other values like arbitrary imputation or mean imputation, etc. Pause the video and then work on the challenge. So when it comes to filtering, we have in the past gotten to learn how to filter using Boolean indexing. In our case, we can also learn how to perform filtering using other techniques, such as using the query method. So let's load this data set. And assuming we wanted to get the records with transaction amount greater than 1,000, so we can decide to reference the data frame that we want to work with, then use the apply the query function or method. You can call it a method, and then we specify a string which will contain just the condition that we want to apply. So transaction amount, here we're just using delimiter characters to specify the column names, and here we're just using them because the column that we are working with has multiple words. If we don't have multiple words for this particular column, like transaction amount, we have left out these characters out. So transaction amount is greater than 1,000, and we can use greater than or equal to, not equal to. Not equal to, you can just do something like this, that's not equal to. Yeah, so greater than 1,000, and then we filter that. So let's run this, and we should be able to get records with greater than transaction amount greater than 1,000. Pause the video and then work on the challenge. We can also combine multiple filtering conditions still using the query method. So here we have just one condition, but we can have multiple conditions, and we can use the logical operators like we did in the past. So in our case here, we have one condition, balance, and you can note here we don't have delimiter characters as we do have here because this doesn't have multiple words. Balance just one. Let me even load this data set so that we can be able to see what's happening. Balance. So we can see here balance is greater than or greater than 5,000, and we even closed it, and we use the logic operator and to be able to include other operators. And here we can, instead of ampersand, you can just use or for and or if you wanted. So so overdraft limit is greater as less than 2. So if we run this, we should be able to get records that satisfy these two conditions. So balance is greater than whereas balance is greater than 5,000, and overdraft limit is less than 2. Yeah. Pause the video and then work on the challenge. We can also decide to get some statistical summary. It will just give us measures, statistical measures all together that pertain to the numerical variables in our data set. For example, in our case, if we have this data set, which we save in DF data frame, we can apply the describe method to be able to get the statistical measures pertaining to the numerical columns that we have. So if we run this and get the outcome, so we can see that we have numerical variables, and we have now some statistical measures that we can be able to use for just for further analysis. For example, count, we can see that all the values within our, we have count 70, which just means that all the records, all the variables have 70 values. So there are no missing values. If you had maybe 69, you'd have noted that there's those 69. There was one missing value in such a case. Pause the video and then work on the challenge. Sorting and filtering. So let's go back again to Boolean indexing, which we got to learn in the past. So with Boolean indexing, we can be able to sort for, we can be able to filter for values, but at the same time, once we filter, we can also sort. But in our case here, we're just going to sort first, and we'll get to sort based on a multiple criteria. So let's load this data set. And what we're going to be doing is to sort our data by account balance. So account balance, and also by transaction amount. So the last transaction amount. So, and we set that we want to sort account balance in descending order and last account amount in ascending order. And we can do that for as many variables as we want altogether. So our sorted data frame at the very end will look like this. So if you look at this closely, account balance, it's in descending order. It starts from 14,800, 14,500, and then last transaction amount, if we can be able to see, it's in ascending order. So you'll get to see here it would only apply that if we had this as a category, assuming that we had this as account balance as a categorical variable, we would have actually sorted, we would have seen uptown branch, then you'd have seen the values being sorted out accordingly. You can even actually do that. Let's switch, because it's hard to see the operation in action if we use two variables which are numerical in nature, but if we use them as such, we should be able to see now. Okay, so branch, we are sorting it in descending order, so from Z or Z to A. So we're starting from the bottom, so uptown branch, that's U. Then for uptown branch, last transaction amount, we are sorting it in ascending order. So let me load up last transaction amount in ascending. So you can see this is uptown, but you can see 180, 190, 200. So we are going upwards. So this actually makes it easy to see the effect of having multiple criteria defined. So once we do that, we can then decide to also, get to learn. We could have also used, sorted DF and filtered, but again, we may not necessarily need to do that. But this is also a section that contains just two concepts in one. So we can also perform filtering using multiple conditions and using Boolean indexing as shown. So we reference the data frame, and then we inside these square brackets, we specify the conditions, the two conditions that we want to work with, and use the ampersand sign to specify that we want to have multiple conditions checked. All right, pause the video and then work on the challenge. Encoding data using the map function. So sometimes you might have categorical variables in our data set. So for example, if I run this code, I should be able to see that we have a categorical variable here, the same case here, the same case here, and same case here, and also here. So sometimes you might want to convert the values for these categorical variables into numerical representations. And how do we do that? We can use various methods, various techniques. They're called encoding techniques. In our case, in this situation, we are going to use the map function, which will allow us to be able to define the respective values that we want to use for each and every value within a categorical variable. Like for example, we would set male using a dictionary. So inside the dictionary, we set key value pairs. So we have male and we want to represent it as 0, then female as 1, and then close that and have that as saved as gender map, and we pass that to the map function, which we apply to the column name that we want to perform encoding or to encode or to perform our own encoding operation on. So in our case, we want to perform or to replace the categorical values within the gender column using the these particular mapped values, and we do that as shown here. And voila, that's what we do. We would need again to determine this. The only caveat with this method is that we would need to determine the values, the unique values in each categorical variable, and then be able to define them with a value that we want. It's not the most efficient, but in some quick, situations like you need to quickly encode, you can also use this. There are other techniques that we can use. There's label encoder, etc., that we can also use. Yeah. Pause the video and then work on the challenge. All right, lastly, random sampling for data analysis. Sometimes you might want to work with a sample of a data set. So instead of working with maybe 1,000 or 10,000 records within a data set, we might want to get a random sample, which, you know, just ensures that each record has been given equal chance of being selected. So how do we do that? We use the sample function. So in our case here, we might decide to only just select 5 records. So we use the sample function, then we specify the number of records that we want, 5, and then we can set random state. This parameter would allow us to be able to reproduce our results. So if you run the same code, you'll get the same results as I am, because I have set this random state to 1 and you have also set it to 1. But if I run it as random state to 1 and you run it as random state to 42 or any other number aside from 1, you'll get different results. So random state just allows us to have reproducibility aspects to this. So, and you can also if you just want to get a random sample every time, you can always just give it a number. It could be 5, 10, 53, but the number has to be lower than the number of records within your data set. All right, so let's run this and we should be able to display the sample data. So this is what we have. If you run it again, you'll still just get the same records, 19, 55, 10, because of random state. But if you change this, or if you change this maybe to 2, you'll get different records. So, all right, so I think that's it. Pause the video, then work on the challenge, and then we can wrap it up. All right, so I hope you were able to learn a few things. You're able to practice a few concepts in relation to pandas. Again, the idea is that by the end of it all, you should be quite confident when it comes to working with the pandas library, and you can be able to work on, you know, projects of whatever complexity. If you did love this experience, and if you want us to tell us that we're doing a good job, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future challenges, be sure to subscribe, and see you in the next challenge. Bye-bye.